Hi everybody, welcome to another video in statistics. Chapter 2, Organizing and Summarizing Data. The first section we will talk about organizing qualitative data. So the one that go with properties, attribute characteristic, and not numeric. When data is collected from a survey or design experiment, we cover that in the first chapter. Now we will organize them. Right. So the way to organize them is we can use a table or graphs, or in the next section we'll talk about numerical summaries. Right, some definition. Frequency distribution will list each category of the data and the number of occurrence for each category. So pretty much we count, we list how many type do we have and how many we have for each type. The relative frequency is the proportion or percent of the observation within the category is found using the formulas. So the relative frequency is the frequency over everything. Relative frequency distribution will list all the categories or data with relative frequency. So we talk about the frequency distribution. So it is like a table. So each category and the occurrence for each category, so that is the frequency distribution. And then the relative, we divide by the total, the sum of all the frequency. This one actually equal to the total numbers of data points. Or the number of individuals in the data set. And once again, if we want to list that as a distribution, so that means we'll list the category and the relative frequency. Right, let's look at the first example. The data below represent the color of M&Ms in the back, and here's how the categories. So pretty much the question asks us to construct the frequency distribution and then the relative frequency distribution. So that pretty much is a table. So we list all the categories and how many we have for each category. So that different way to do that. Either when we see that will be brown, and then every time we see one, we just plot out a line. So that would be 1, be 2, 3, 4, 5, 6, 7, and 8. 9, 10, 11, and then 12. So that 12 times, we just say that occurred 12 times. We don't have to tally that. The thing is just the categories and how many times we have for each category. Alright, next we have yellow. I'm just going to say use this color, yellow. Yeah, we don't have to tally like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right, next red. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right, next will be orange. I use red as well. One, two, 3, 4, 5, forgot the last one. 6. Right, next is blue. 1, 2, 3, 4, and then green. 1, 2, 3, 4, 5. Forgot a brown. I actually count this BB before the video so I don't make mistakes. So how many we have for green? 1, 2, 3, 4, 5. Yeah. So just be careful with the counting. That should not be a problem. So of course we don't have to draw the tally, just the category and how many times we have for each category. So that is the frequency distribution. So pretty much just counting. Right, next we construct a relative frequency distribution. So we copy this from the previous page. Right, so just copy this from the previous page. So brown we have 12, yellow we have 10, 9 red, 6 orange, 3 blue, and 5 green. So that's what we have. So this is the frequency distribution. Now the relative frequency distribution, we have to say how many we have that relatively to the rest of them. So for the relative frequency distribution, what we do is we'll add all of this up. 12 plus 10, 9, 6, 3, and 5. We have 45. So the total is 45. Now the relative frequency is those number relatively to 45. So we're going to say 12 divided by 45, 10 divided by 45, 9 divided by 45, 6, 45, 3, 45, and then 5 over 45. Right. And then of course we convert that into percent. Right. So 12 divided by 45, so be that 0.266 7. So that will be 26.7%. Should be careful on the question on the homework or test. Make sure pay attention on how many decimal number do they want. That's 0.222 or 22.2%. 9 over 45, that is a 20%. Alright, by the way, to get the percent, we divide by decimal, then move to divide, then get the decimal number, and then move the decimal point 2 places to the right to get percent. 6 divided by 45, 0.133, or 13.3%. 3 over 45 will be half of that, 0.0667. So that's about 6.67%. And then 5 over 45, 0.111 or 11.1%. Right. So the relative frequency distribution, it will be have the categories and how many we have for each category relatively to the total number. Right. So that's easy. So the distribution pretty much just a table. Next, to visually display this, we can use a graph. So bar graph is constructed by labeling each category of the data on either horizontal or vertical axis, and then the rectangular or the bar to be drawn for each category. The bigger the bar, the higher the bar, the bigger the numbers there is. Right. Now, the next we construct based on this information. We'll construct a frequency bar graph and then the relative frequency bar graph. So the frequency bar graph, we use the frequency, and the relative frequency bar graph, we use that relative frequency. Right, so there will be 6 categories and the maximum number is 12. So keep that in mind. So I'm going to write right. So 6 category, and this is once again this is qualitative data, so it doesn't matter, we can rearrange them anywhere we want. It doesn't have to be in the order because we don't have the order in this color, right? And then it go up to 12, so we have to choose something that big enough to have 12. So see, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, that's good. So we say 2 4 6 8 10 12, and this will be 14. Right, now then we'll just draw a bar for each. Let's say 1 2 3 4 5 6. So first we have 12 for the first one. So and then next we have 10. Of course we should use the ruler, but since they are grid, I just brought this by hand. 9. 26. Oh, brown, yellow, and then red, and then orange 6. And then blue 3. And then green is 5. Right. And as always, for any graph we should label them. So we say colors or frequency distribution. We should not say distribution because distribution refer to a table. So we say frequency of colors of M&M. Right. So that is the frequency bar graph. Next we will use pretty much the same thing, but using the relative frequency bar graph. Now, the nice thing about this is the length or the height of those columns or those bars will be exactly the same as for the frequency and the relative frequency, which is labeled differently on the left hand side. Yeah. Right. So we exactly can draw the same thing, or we can just label based on the percentage. Let's say 20. Let's say 4% each. Be 4, 8. Right. So 4%, 8. We should write that as decimal. 0.04, 0.08, 0.012, 12. 16, 20, 24, and 28. Or we can just draw exactly like this and then just relabel them. All right. But so this is going to be a little bit different. The first one is 26.7. So the next one, 22.2. We round that. Yellow. And then red, 20%. Exactly. red. Orange is 13.3%. Blue 6.67%. And then green 11.1%. Yeah, so we say relative frequency of colors of M&M. Right, so just that. Yeah, so the thing about the bar graph is the bar graph is for the qualitative data, so we cannot have any order, or we can put them in some certain order, but the thing is the scale on the horizontal axis is not really important, and we have the space in between, so that is the difference between the bar graph and something else we study in the next section. Right, talking about orders, if we arrange them in decreasing order of frequency, so if it is in decreasing order of frequency or relative frequency, this is called the Pareto chart. So decreasing order of frequency, so that's what we have here. Right. So once again, the bar graph is just the bar, and there will be space between the bars. On the vertical axis, in this case, it could be frequency or relative frequency distribution. I mean, relative frequency or frequency. Again, if we want to label them, we can just say it on the right, frequency, and this is relative frequency. And obviously the horizontal axis is color. We can label them as well. Right, so just like this. Right, I said the title of the graph, the title for the axis. I mean, this is clear enough, so we just say color. Right, so the Pareto chart is just the bar graph with decreasing order of frequency or relative frequency. Yeah, so just have that. Next, we have the side-by-side bar graph. The nice thing about the bar graph is we can put a bunch of different bars for different data set, and those are called the side-by-side bar graph. And suppose we want to know, we can do the comparison between the frequency or relative frequency. Alright, next. Here's an example. The following data represent the marital status of U.S. resident from 18 years or older from 1990 to 2006. Draw a side-by-side relative frequency bar graph. Right. Now, the question is, why can't we use the frequency bar graph, but we have to use the relative frequency bar graph? Right. Let's just do that first, and then so this is the frequency. Now we just have to have the relative frequency. Right, we add all of this up to see what is the total. 40.4, 112.6, 13.8, and 15.1, and 181.9. Right, and we just divide that to the total number. 40.4 divided by 181.9, that is about 20. Okay, so 0.222 or 22%. 112.6 divided by 181.9, 0.619. Right, 13.8 divided by 181.9, 0.07576, about 7.6%, and then divorced 15.1 divided by 181.9. We have 0.083 or 8.3%. Of course, we can verify and add all of this up. That should be 100%. Right. Now we do the same thing for the relative frequency for 2006. $55.3 divided by, sorry, we need the total first. $55.3 plus 127.7 plus 13.9 plus 22.8 to 19.7. Right. Now, because of the total numbers are different, we cannot use the frequency, right? Think about that. If we have 100 people, 181 million people in 1990, and then we have 2006, and if we put them, of course, that in 2006 we tend to have all of that bigger numbers, right? So we just look at the numbers, all of them are bigger, so that's not really compared to it. But if we divide by the total number, we get the percentage. So in that case, the total number add up to 100% for each of them, for each year. So in that case, we can compare them. So if the total number are the same, we can use frequency distribution. But if the numbers are not the same, we have to use the relative so that the total number will be the same. Right, so now we divide 55.3 divided by 219.7. 0.252 or 25.2%. 127.7 to 19.7. 0.581, 58.1%. 13.9 divided by 219.7. 0.633 6.33% and 22.8 to 19.7, 0.104 or 10.4%. Right, now we'll draw a table, a graph, I mean. So there are 4 categories each, and each of them we have 2 bars. So we just say 1, B2 category, 3 and 4. Right, just label them never married. Married, widow, and divorce. Here we can write that as a total. Horizontal axis is marital status, and then the vertical axis is percentage. The highest one is 60%, 60.1%, so we should make sure we have that. So 10, 20, 30, 40, 50, 60, so that's good enough. So 0.1, 0.2, 0.3, 4, 5, and 6. And on this we write relative frequency. Right, never married. In 1990, that's 22%, or 0.02. So between 0.2, 0.3, that will be 0.25, and half of that. So we are the column here. And then in 2006, that's 25.2. And then 61.9 for married in 1990, 61.9, about that, about there. Again, we have space between the bars, but side by side we can just put next to each other. And then 58.1, and then 7.6 in 1990. We do 7.6. So that's 0.5, 0.75, so 7.6, so about that. and then 6.33, a little shorter than that, and then 8.3, and then 10.4. And here we draw the legend. If we use this pattern and this color, that in 2006, I mean 1990, if we use the other pattern and the other color, sorry, this should mark this direction, that in 2006. And finally, the label. So this is marital status, in 1990 and 2006. Right, so that is side-by-side bar graph. So just a bunch of bars, there will be space between them. The category we can scramble, it doesn't really matter. But yeah, just have the label and everything. Right, and of course if we don't want the vertical bars, we can use the horizontal bar, and that just work out just fine. Here's an example of that. Next we have the pie chart. Again, this is also for the frequency, I mean for the qualitative data. So we're not talking about numerical data. Right, a pie chart. A pie chart is a circle divided into sectors, and each sector represents a category of data. The area of each sector is proportional to the frequency of the category. Right. So again, we cannot use this and then put on the table. We have to use the relative frequency distribution. So this is okay in 2006. So I'm just going to copy from the previous page the relative frequency for 2006. I'm going to use this numbers. So the next one will be relative frequency. (0.252) or 25.2%. 0.581 or 58.1%, and then 0.63. This is 0.0633, sorry, because that's 6.3%, and 0.104, so that's about 10%. Right, now the first one is easy. I would say 25.2%, so that is about a quarter of a pie. The whole thing is 100%, so we will have about 25%. So let's make a 90-degree angle on that. So from the center, that is 25.2%. And we can label the numbers in here. right? Actually, have a projector here, so we should convert to degree to get the better graph. Right, next, so we label for this parent in this color, that is never Mary. Right, next, Mary 58.1%. How do we do that? Right, of course, so 50.8%, so that is more than 10%, more than half. And then a little more. But how much more? Right, so the better way to do this is using the degree. So if we have 100%, just use 100 is equivalent to 360 degrees. Now we have 58.1. What is the equivalent degree? Just want to say x. Right, so now for this, just set up the ratio, make them equal to, and cross multiply. So 100x is equal to 360 times 58.1. So that 20,916. Now we divide by 100 on both sides. We have x equal to 209 degrees. So because 100% is 360 degrees, so 1% is 3.6 degrees, and which is multiplied all of this by 3.6, works out just fine. So again, if we take the half of the circle, that will be 180 degrees, right? And then we need about 29 degrees more. So if we want to measure it, about 20 more, 20.9 more, so about 30. Right. So this is 58.1%. Right, we use this. Actually, is for Mary. Right, next 6.3%. Now think about this. A quarter is 25%. 6.3% is about a quarter of it, right? 25 divided by 4 is 6.25. So 6.3 is about 25% of a 25%, right? So ideally we will divide this into, cut this in half, and then cut in half again. So that much is about 6.25% or 6.3%. The nice thing about this is we don't have to put them in the order, right? So we can just say this part, once again, what I do is a quarter, 25%, I cut that into 4 equal pieces, and then cut that into 4 equal pieces. So 25% of a 25% is about 6.25, which is 6.3. Be close enough. So we say this portion is 6.3%. So this color from this pattern is for video. And then what left is the 10.4%. Right. Right. And as always, there should be a name for it. So the pie chart, we have the pie and the legends, and then all together we say what is the mineral status. In 2006. Right. Ideally, of course, we convert everything to degree and use the protractor. But if not, we can use the percentage relatively to a pi, like 25%. So that's a quarter per pi, and so on. So I stop the video here, and then we pick up from the next section. As always, thank you for watching, and see you in another video in statistics.